Hello guys, welcome back to our channel. So again today we have Shomu sir with us. So Shomu sir, what are we discussing today?
Another CAT problem, Harshal. We are doing an interesting one. It gives us a basic proportionality ratio. I mean, what do I mean by that? I'll come to it. So let's get into the problem first. Train T, train T leaves X for Y at 3 p.m. Fair enough. So you know the source, the destination, at what time it leaves. Train S traveling at 3/4 of the speed of T. So initially it has been mentioned the relationship of speed between S and T, right? Not the value of the speed, but the relationship of speed between S and T. Leaves Y for X at 4 p.m. So it is traveling in the other direction, right? So T is traveling from X to Y and S is traveling from Y to X. Also starting at two different times, relation of speed is mentioned. So when you are registering what information is given, so you may not look at 3 p.m. to be exactly what it is, 4 p.m. what is it. You may not look at the data to begin with, but you should understand what type of information is given, right? So we know that when train T leaves, we know when train S leaves, we know the relationship between train S and train T's speed, right?
Right.
The two trains pass each other at station Z, where the distance between XZ is 3/5 of the distance between X and Y. And X and Y are the two extreme points, right? So if I have a relationship between XZ and XY, I can very well calculate the distance, or rather establish a relationship between the two segments that the train has traveled. So what I mean by that is, if this is X and this is Y and this arbitrary point, let's say Z, if I have a relationship between XZ and XY, a ratio, then I can also establish a ratio between XZ and YZ, right?
Right.
Now, why am I focusing on that? Because one train is starting from here, another train is starting from here, and both meet at point Z. So one of the train has covered XZ, another train has covered YZ, isn't it? From the perspective of the question.
Correct.
So now, if we look at this, the question that we're looking for is how many hours does the train T take for the journey from X to Y? Now, think about this. I mean, distance is not mentioned. Actual distance not mentioned. Actual speeds not mentioned. The only thing that has been mentioned is a relationship between the speed, a relationship between the two segments of the distances, and a relationship between, or not a relationship, the starting times of the trains respectively, right?
Right.
So let us try to visually understand the relationship that is provided. So first of all, let me elaborate the distance thing. So we have XZ as 3/5 of XY, right? Or just let me just make this a simple one. So XZ upon XY should be 3/5, right?
Right.
If I consider XY to be 5, XZ is 3, leaving 2 for ZY. So the distances of these two segments should be in the ratio 3:2. Let me just write this a little better. So 3:2, right? We also know the train T that is covering XZ and the train S which is covering YZ, the speeds are in the ratio 4:3. Read this properly. S speed, this is the part S is covering, and this is the part T is covering. The speed of S is 3/4 the speed of T, right? So S by T is 3/4. So if this speed is 3, then this speed is 4. Right. So let me just take this extra bit off. So sorry, not that. Yeah. So the speeds are in the ratio 4:3. Now, what is the relationship between distance, speed, and time? Time is distance by speed.
Right.
Ratios can always be multiplied and divided. It cannot be added and stuff, but you can always multiply or divide ratio. So what I mean by that is, if the distance are in the ratio 3:2, if the speeds are in the ratio 4:3, then the times should be in the ratio 3/4 is to 2/3. Just cross multiply and make this ratio proper. So we have 9:8, right? 3 multiplied on this 3 and 4 multiplied on this 2, or simple words, multiply 12 to both the parts. So we have a ratio of 9:8 between the times, right? The time to travel this distance and this distance. Now, what do we know? The train starting from here started at 3 p.m. And the train starting from here started at 4 p.m. obviously the train which covers XZ must have traveled for 1 extra hour.
Right.
So just look at this values here. 9 and 8 already has a difference of 1 hour, right?
Difference of 1. Right. Right.
So if I say that this distance is covered by train T in 9 hours, then this distance must be covered by train S in 8 hours.
Right.
And that will automatically create the difference of 1. Now you might wonder, what if not? So for example, just an arbitrary one, just a small one. So suppose this was 5:3 in some way. Don't ponder on it. So some way we get the time ratio as 5:3. Now you notice that the difference between 5 and 3 is 2, right? It's not 1 anymore. But the data point is not changing. I mean, 3 p.m., 4 p.m., so there's a difference of 1 hour, right? It doesn't suddenly become 2 hours, right? So in order to get the difference to 1 hour, simple, just divide each part by 2. So we have 5 and 3, a difference of 2. We have to get it to a difference of 1. So divide each of them by by 2. So you get 2.5 and 1.5 hours. And 2.5 and 1.5 hours are automatically at a difference of 1 hour, right?
Difference of 1. Right. Right.
But in this case, we're lucky enough that we are getting a difference of 1. So hence that should be the actual time of travel, right? So we can always scale the parts to the actual data. So actual data is difference of 1 hour. The parts are 9 and 8. Establish a relationship. That's it. So now that we have established this, so we have got the traveling time. This is the first thing that we determined. Remember, at the beginning, we did not have any number, right? We did not have the speed value. We did not have the distance value. All we had are relationships. But this 9 hour and 8 hour are the actual traveling times now for XZ and YZ, for T and S, right?
Right.
Now, what are we looking for? We are looking for how many hours does train T take for its journey from X to Y. So this S becomes irrelevant, sort of. So let's focus back on the distance. So we have a distance of 3 and 2 for these two parts, right? And from perspective of T, we already know that T covers this 3 with a speed of, this covers this distance of 3 in 9 hours, right?
Right.
So effectively, these two parts, T should cover in 6 hours.
Right. Right. Right.
And since we are looking for the total time for X to Y, that will be 9 hours plus the 6 hours, or our answer will be 15 hours.
Okay.
So just a simple relationship between the ratios and whatever is given. Establish the right relationships and you'll get the answer very easily. That's it.
Okay. Interesting question, interesting solution. Thanks a lot, Shomu sir.
Thank you, Vashar. And thanks to everyone for joining in.
Thank you guys. Thanks for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.